Another one, again, using identity here. Sine of x plus cosine of x equals 1/2. Maybe sometimes we need to do something to both sides, and maybe with a little bit of intuition of where we need to go from here. Again, a lot of these are like solving a puzzle, so have your identity sheets nearby. I think I have a double angle identity here with sine, but wasn't sine of 2x 2 times cosine x cosine x? So if we multiply both sides by a 2, sine x cosine x was sine of 2x. All right, now we're getting somewhere. We have a multiple angle here. So for what values of sine equals a 1, that occurs at pi halves. So I take my angle at its value equals pi halves. And then we know that I have a value occurring every 2 pi past that. So plus a factor, a multiplication factor of 2 in pi. Let's divide everything through by 2 to solve for x. So x equals pi fourths plus n pi. So there are my solutions to this equation. I want to find all the solutions between 0 and 2 pi. So pi fourths is one solution. And then if we set, so x evaluated at 0 is just a pi fourths. And then if I wanted to use 1 as my value of n, that would be pi fourths plus pi. Pi fourths plus pi is 5 fourths pi. If I added 2 into that at x equals 2, or at n equals 2, that would be pi fourths plus 2 pi. And that 2 pi extends it beyond my interval that I'm looking for solutions at. So my only solutions then would be pi fourths and 5 fourths pi. And to add another wrinkle as well, let's see how we can kind of explore this one. So can you imagine any identities here that might be useful? Sine squared minus cosine squared x, all those squared, that would be useful because that always equals 1. So okay, maybe you're right. Maybe what we can do is let's square both sides. So I can go ahead and take sine squared, or sine x minus cosine x, square that side, and square this side. Okay, all right, I think I see where you're going now. So let's multiply that one out. So that's a sine squared x minus a 2 sine x cosine x plus a cosine x squared, or cosine squared x equals a 1. Let's rearrange some terms. So I have a sine squared x plus cosine squared x minus a 2 sine x cosine x equals a 1. Sine squared x plus cosine x, all that right there is just a 1. So now I have 1 minus 2 sine x cosine x. All right, well, I started with sine and a cosine. Now I'm still with a sine and a cosine. I don't know if we made any progress there at all. Let's subtract 1 from both sides. Divide both sides by -2. Okay, well, that might be something I can deal with. That's true if sine of x equals 0 or cosine of x equals 0. All right. And so what values of x do I get a sine of 0? That occurs at 0 and pi. Cosine of x is 0. Occurs at pi halves. And 3 halves pi. Okay, I found 4 solutions that are all within this particular interval. If I add multiples of 2 pi to any of those solutions would need to be excluded because of my exclusion to begin with. And now what I just want to do is I just want to check those solutions to see if this equation right here is true, because we may have introduced an extraneous solution. So let's look at sine of x minus cosine of x equals 1 for x equaling 0. So the sine of 0 minus the cosine of 0 equals 1. Is that true? The sine of 0 is 0. Minus 1 equals a 1. That is not true. So my first solution is sine equaling 0. Let's have a nice put together color like that. Let's do it that way. All right, so that one. Then we have the sine of pi halves. Let's check the sine, or let's try this solution since we're going around the circle. So the sine of pi halves minus the cosine of pi halves. Does that equal 1? The sine of pi halves, that value is a 1, minus the cosine of pi halves, which is a 0. That equals 1, so that one is true. All right. Let's try pi then. Sine of pi minus the cosine of pi equals 1. The sine of pi is a negative 1. Sorry, it's a 0. Minus the cosine of pi, which was a negative 1. 0 plus a 1 equals a 1. So that one is true. And then the last one we have is the cosine of 3 halves pi. So the sine of 3 pi halves minus cosine 3 pi halves equals 1. Cosine of 3 halves pi is a negative 1 minus a 0 equals a 1. That's not true. Likewise, that first one I did was not true. So I have another solution that is also invalid. So my total solutions for this to be true are my solutions at pi and pi halves. And I introduced 2 extraneous solutions in this process. All right. Now again, these are going to take lots of practice, and I get it because you're trying to figure out how to solve something that looks very unfamiliar. The more we practice with our identities, the more that we try things, the more that we just keep kind of muddling through and trying to figure out how these puzzles unravel, the more likely you're going to get them earlier in the process. But don't feel bad if it takes you 1, 2, 3, or 4 tries to get there.